Before we run our kernel, we will need meaningful data for that kernel to operate upon. I've created a naive managed resource called host and device memory pair. Both of these variables represent the same data, but on different sides of the system. You can think of this as the CPU side and this as the GPU side. Why two variables for the same data? First, CLMem is an opaque type. Only our OpenCL kernel code knows what's in here. Secondly, which type of memory you need depends on where the logic is occurring. If we need to operate on memory within our C code, we'll need this. If we need to operate on memory within our GPU kernel code, we will need this. It's not always necessary to have a host and device side copy of the same memory. However, to keep things simple, we will always do it this way. We will need 3 instances of this object because our kernel takes 2 inputs and has 1 output. We will allocate the memory on the host side here. Each vector will have 16 elements. We multiply the list size by the size of an integer to get the total size of the memory in bytes. We then cast to a pointer to integer. The cast is not necessary, however, I do it for clarity. After mallocing the memory, we need to override the junk values with something more meaningful. Input vector A will be 0 to 15. Input vector B will be 16 to 1. After running our kernel, we will expect every slot of vector C to contain the number 16, because 0 plus 16 is 16, 1 plus 15 is 16, 2 plus 14 is 16, and so on. This tutorial does not contain any meaningful output, so I'll put this here. If we see this print statement, we will assume everything went okay, we didn't get any seg faults. Let's give this a run and see what happens. I can see my output, everything's okay. We're ready to go on to the next tutorial.